So in the previous segment, we heard about how with the new EXTREVA ASE, we could drastically reduce cycle times, right, by virtue of the dynamic and the gas assistance. So I wonder, Ed, how EXTREVA ASE can help labs meet the most pressing challenges?
Yeah, that's a really good question. It depends on the laboratory type. There are several types of laboratories that have different needs, and one of them is the contract testing laboratories, which are generally large multi-laboratory organizations, and what they need is high throughput, and they look at cost per sample very carefully. So they want a very easy return on investment for an automated system like this. That's very important.
Right.
Okay, other types of laboratories like municipalities and state laboratories, they often are looking to comply with regulations and validate their data. Why? Because they are targeting communities, public water supplies that are worried about public health. And that's very important that they get the right result. Okay, other types of laboratories could be, for example, in academic institutions or government labs. And academic institutions really need to publish data, right? That's what's driving them. And so they need to develop methods, publish data, so that way they can get faster to publish with an automated system. And that's really important for them. And the government laboratories are looking at cutting edge research, sort of some unknown contamination, newer organic contaminants. And so the EXTREVA ASE can help them extract them from different types of matrices.
Right.
So that's another type of area that they're interested in. And then finally, food laboratories are another one, food control labs. So EXTREVA ASE can go beyond environmental samples, and that's really important to note here.
Of course.
And so in food samples, where PFAS, it turns out, could be even a major concern in food than it is in for example, in drinking water. And so these laboratories need to make sure, if you're a food control lab, say for a large food manufacturer, you want to make sure that you protect your brand. Your brand image is everything. Once your brand image is tainted, that's a really problem. And a lot of these big brand names are realizing that PFAS could be a problem, and they're looking at food packaging material and other things that could be causing them a problem.
All right, so if I were to recap here, contract tested labs, EXTREVA offers, thanks to dynamic and gas assistance, a significant reduction, highest throughput. From a standpoint of laboratories, at governments, and food testing, it's reliability, integrity of the data, traceability. And now from an academician perspective, thanks to the automation, fast turnaround in publications because they can process more samples faster. But I wonder, Gopal, how easy is to tune a method in the EXTREVA ASE for these type of scenarios when you're dealing with the unknowns, right? Like we talk about a lot about the regulatory market, but I'm curious, how does it work in terms of like, non-regulated and, like unknown new methods, new compounds?
You can play with the method very easily. For example, you can play with your extraction time, first of all, right? So if you look at, like, let's say PFAS, right? So if you look at some other methods of the PFAS extraction, they are generally 15 to 30 minutes. We optimize our EXTREVA to 5 minutes extraction time. And if you look at the recoveries of the PFAS, they're excellent recoveries. And then you can also play with your, to move it faster, the turnaround time, you can play with the evaporation. So you can bring down your vacuum pressure. That will help you to evaporate faster. You can play with the temperature and pressure also.
Right.
So it's very easy to optimize EXTREVA.
So if I understand correctly, you can play with different parameters at the extraction and the evaporation. I guess in the extraction that will also include like temperature, the extraction solvents,
and
so on
flow
and so
rate
forth.
also.
And the
solvent flow rate, yes.
And I guess we haven't talked about this yet, but one key component in the EXTREVA, especially for laboratories seeking for either regulated or non-regulated, is the versatility, I guess, of the sample size. Is it something you can talk to us about it?
Yeah, that's a very good question. So the regulatory agencies, they like to have the sample size a little bit high, just to reduce the RSTs. But if you want your sample size to be low, that will help you reduce your turnaround times very significantly. Because once you have your sample size small, then the total volume of your extract gonna go down very significantly. And then you're not gonna need much time to evaporate that smaller volume of extract.
Right, and if I understand correctly, you mentioned about like, it was most like a recommendation usually from regulatory agencies, right, to certain sample sizes.
Correct.
But EXTREVA, if I understood, please correct me if I'm wrong, it offers both, right? So the ability to be compliant.
Yes.
And also play with the instrument methods and features.
Yeah, correct, because you could, in some of the methods, they specify the amount of sample they want you to weigh into the sample for the sample weight. So say 1 or 2 grams of sample.
Right.
But of course, if you're doing non-compliant work, you can use any sample size. And the good news is we have sample cell sizes that are different, from smaller to larger sizes, to accommodate a wide range of sample weights.
So what is the minimum sample size we could pack and run in an EXTREVA ASE system?
Yeah, I'd say around 0.5 grams or even less.
Oh wow,
Yeah.
That's amazing. And what would be the largest sample size could be typically tolerated?
We have 100 ml cells,
right.
So you can fit 20 grams of samples easily there.
Oh wow, that's a pretty broad range.
Yep.
Awesome, thank you very much for this segment.